Welcome to the second day of the winter school. What I would like you guys to know is that we are going to do something different today because I really love to hear the sound of your voices. So, if you see these ones, when you ask me a question, ladies and gents, I would really just love to hear it nicely, and the guys at the back and the front and left and right would like to hear it. So there's a red button of power that you press and then it lights up. Test 1, 2. Then it is live. So ladies and gentlemen, if you've got a question, I'm going to ask you that you just get to a mic. If there isn't one in front of you, there should be one close to you. That you just speak clearly into the mic. It's not the time to serenade your friend at this stage. Or the one beautiful lady you saw yesterday. I'm not saying there's only one beautiful lady in the room at all. But if you see more than one beautiful lady, maybe focus on one. Okay? So ladies and gentlemen, we had lots of fun yesterday. I don't think any of you ever thought that maths could be fun. It was fun up to a point until I started having fun, then it's not so much fun anymore. But I realized yesterday as I was driving off that we focused so much on parabolas that we really haven't touched other graphs. Good morning, sir. Okay. Greetings and salutations. I said exactly what I wanted to say. Okay. As I said yesterday, I really love words. I love playing around with words. That's why I love dad jokes. So, what I want to do is just for the first 20 minutes or so, I want to just quickly venture off back into yesterday and do a sum about hyperbolas. And throughout the course of the day, I might pop in a sum about exponential graphs as well. So what I'm going to do for a start, I'm going to give you, let's make it 7 minutes to do that sum for me, please. And now you would not have seen the sum before because I thought about it as I was driving in this morning. Okay. Given f of x is equal to a over x minus 2 plus q, which has an axis of symmetry of y equal to x plus 3 and passes through the origin, determine the values of a and q, make a neat sketch of f to the negative 1 of x, and then give the values of x for which fx over f accent of x is greater than 0. You have 7 minutes, ladies and gentlemen. You can please plan your journey and then go for it. Now, ladies and gentlemen, I do this on purpose because number one, it's fun. For me at least. Number two, for your prelims and your finals, these are the kind of questions that they love to ask, especially prelims. Because the teachers, if you are in a school and the teachers have big egos, they love to make the prelim really tough, and you guys think you're going to fail and then you do much better in the finals. That's how it works. So let me quickly Let's quickly start by digging through the information. It says that f of x is equal to a over x minus 2 plus q. What can I read off without doing anything? I can read off the vertical asymptote. And it's not 2, it's x equal to 2. Okay? That's the only thing I can read off, except that I know it is a hyperbola. That's all I know. Then I've got to kind of go and say it has an axis of symmetry of y equal to x plus 3. Y equal to x plus 3. Why is that important? Tell me, why is that important? Grade 12s, come on. The axis of symmetry passes through the intersection between my vertical and my horizontal asymptote. So that coordinate there is going to be 2 comma something. If you didn't know that, your toolbox is maybe a little bit empty at this moment. I'm pre-warning you, we are going to ask you about axis of symmetry because we know you guys don't know your theory. It's not difficult, but this means for me to get the Q value, I need the Y value. But I know it lies on that line. Can't I then just get the Y value? Yeah, just sub in. So Q is equal to 2 plus 3. So Q is 5. So I know that fx is y over x minus 2 plus 5. Now, I need A. Can I read off A? No. So what must I do? Substitute a coordinate. Well, I know that the graph passes through the origin. So 0 is equal to A over 0 minus 2 plus 5. Now we solve A. So positive A over 2 is equal to 5. A is 10. Which means, and I'm just going to write it here, fx is 10 over x minus 2 plus 5. So if I had to draw fx, my graph would be there. Does it make sense? You're saying yes. Why does it make sense? Yeah.
Why does it make sense?
Any of you two, yeah. You or the lady behind you. She's like, no, please, boss, take that. So why do you say?
So because
That's what we call circular logic, okay? It makes sense because it makes sense, okay?
so it's obeying the asymptotes passing through the axis of symmetry.
And
It's a hyperbola.
The A value is positive, which means my graph must lie quadrant 1 and 3. So yes, it makes sense. Okay, it's those small little things that I would love you to start thinking about before you go on to the next question. Now, how do I draw f to the negative 1? Yes, just turn on the mic. I would love to hear that beautiful voice of yours. Yes.
So I would say the first step is to replace the f of x with y. Y is equal to a over x minus 2 plus q. Then make y the subject of the formula.
Okay. Y is already the subject in that formula.
Okay, in the place of x put y, then make y the subject of the formula.
Okay.
Yeah, to get x.
You just wasted your own time. Not saying it's wrong, but you're trying to go to Cape Town by going first to Durban. Would you get there in the end? Yeah. You're going to have a 5 or 6 hour extra drive, maybe 8, but you'll get there. Why don't you just swap all the x's and the y's on my graph? But remember, this will only be a 4-mark question in the exam. So you must kind of be careful, not saying wrong, but I'm saying be clever. I already have all this information, so if I want to draw the inverse, I just swap all the x's and y's. It must still pass through the origin because 0, 0. Then it's going to have a y asymptote at 5. And x asymptote at 2. Ta-da! There's the inverse. All I had to do. All I had to do. Okay? All of a sudden it's much easier than you thought. Remember, ladies and gents, with inverses, x and y swap around. Same with domain and range. Swaps around. And we can test it. Here, my domain of f is x can be any number except x may not be 2. What is my range here? Y can be, so the range of the inverse, y can be any number, but what, sorry, that's not y, sorry. y2 and x5. And except for y can't be 2. Oh my goodness! So the domain of the original became the range of the inverse. The range of the original, y can be any number except y can't be 5, is going to become the domain of the inverse. X and y swap around, domain and range swap around. Now we get to the third question, which is a beautiful freak out question of note. Why, if you look at it, are you freaked out just a little bit? I see you're shaking your head there. What? I don't even know how to derive. If you've got AP maths, you should be, or further study maths, you should be able to derive f of x like it is there, and then good luck with trying to solve that algebraically. Not impossible, but good luck. So ladies and gentlemen, this brings me to a very, very, very important phase of today. Because now we need to start thinking about derivatives, calculus. Arguably, the most important invention of all time. Possibly just right on par with things like the equation, right on par with things like the Cartesian plane, and right on par with the person that invented croissants. I love croissants. Chocolate croissants are the best. Okay. Now, ladies and gentlemen, today is going to be all about calculus. And I'm going to spend the whole of today on calculus because calculus is going to be the future of your maths past matric. The same as your physics past matric. Those of you that are going to do engineering, I'm going to pre-warn you. If you didn't do further study maths, before you go to first year calculus, go and study integration by yourself. But so how do I do it? Khan Academy. Because I promise you, you're going to open your physics textbook. On the first flippant page, they already use integrals, which you only do 3 or 4 months into calculus. So you wouldn't even have seen it before. And the physics professor just goes, okay, let's run with it. Further study maths, guys, your hashtag list. So let's quickly talk. We now have 2 notations that we have used. What are the 2 notations we used yesterday? F of x. We haven't used f accent x yesterday. We used f to the negative 1. So if I've got f of x and f to the negative 1 of x, what is the difference? What does f of x give me? Y value. Position. Listen up. Position. This is going to be important for you to understand today. F of x is simply going to be the position of the y's. So it's a dot. It is a place in time. A dot. F to the negative 1 of x is what? It's also position. Yes, sir? It's inverse, so it's position of the axis. So this is inverse, which is in essence the position of the axis, because x became y and y became x. Today we're going to do 2 more notations. And this is where you need to make sure that you are okay with it. First of all, f accent of x, or dy over dx. Which means what? Which means derivative. And someone said it, I heard it somewhere here. Gradient, almost Okay, instantaneous rate of change, so gradient at a point. This is very important for you to understand this. Gradient at a point. So how the graph changes at a specific place. Why is this so important? I don't think many of you have ever thought about it. Why, if you go to physics, if you go to engineering, everything is about calculus. Even if you go into economics, everything is about calculus. Who can give me a reason why? Yes, sir. Turn on your mic there for me.
Because you can calculate other physical quantities from graphs you already have. So if you change the position, you can get velocity. From velocity, you can get acceleration.
Okay, I love what you're saying. So there are applications thereof. Fantastic, but that's not why. That's an application. You've got to kind of be careful in your mind. If I give you why are you doing something, I'm not asking you for what are your applications. I'm asking for the reason behind why you would do it. Kind of be careful. At varsity, that's going to be a very big difference. So I want to get to the matter why. If I look at differentiation, why is it important? Because for engineers, for biologists, for economists, it's easier to look at how something changes and then work back to find a formula that describes how it changes. That's why differentiation is the start of all engineering courses. That's why it's the start of all economics courses. The same with statistical courses. You do differentiation if you go into it. So this gives me rate of change at a point. As you said here in the front, instantaneous rates of change. Okay? Now if I go to second order derivative, how do I write it? How do I write it in terms of dy over dx if I go second order derivative? Come on. D squared y over dx squared. So if you see that, you know it means second order derivative. Now what is the second order derivative of a graph? You use it for point of inflection, I agree. That's again an application, but what does it give you of a graph? Yes, the concavity. Yay! This girl is on fire. Okay, concavity. What about third order derivative? What does that give you? Nobody knows. It actually has no real life applications, third order derivatives. It's purely theoretical. Okay? Now, if I look at that graph to get back to the question, and this is a very important thing for you to do, is I'm going to mix, in this case, f of x and f accent of x. Because the question is f of x greater than naught or f of x over f accent of x greater than 0? That's the question. So the question that I want to now pose is, how the hell do I answer that? Yes, sir. On the mic there.
So, sir, basically the question is asking us, where is the graph and the gradient of the graph either both negative or both positive?
Okay, I love it. So in other words, well done, sir. I've got to have a positive over a positive, or a negative over a negative. I'm going to do little circles around the f accent of x because I don't have colors. If I were you, I would get two different colors of pens. I would love to have two different colors in the front, but I don't, so I'm going to be creative. So let's start with f of x. So the position. Here I've already drawn f of x. My position is positive, 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 positive until I hit 0. Then it's negative, 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 all the way up to positive 2. Here, my position is positive all the way to infinity. Now if I look at f accent of x, so the gradient, what do I see about the gradient of that hyperbola? Yes, sir, on the mic?
So the gradient is always negative.
I disagree with you. Don't just go, my bad, there's a question you've got to ask. Because there's one place where the graph doesn't exist. So fix your statement for me, please, on the mic.
The gradient is always negative except that x equals 2.
Ah, well done, chap. Okay, so in other words, my graph is always decreasing except at x equal to 2. So if I go to now doing it in circles, it's negative, 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 because it's going down all the way there. Negative, 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 all the way there. So where is the only place where I have either positive and a positive at the same time, or a negative and a negative at the same time? Between 0 and, because here I've got a positive divided by a negative, doesn't work. It does work there, so it's definitely going to be for x between 0 and 2. And it doesn't work from 2 to infinity. So remember, you can always write this as 0 to 2. It doesn't touch 0, it doesn't touch 2. And there's your answer. Any questions on this side? Yes, yes, please into the mic.
So can you please say what you just said again?
Okay, glad, because I'm a bit fast there. Okay? Remember, what we are looking for is a positive divided by a positive, or a negative divided by a negative. So if I go to my graph, here I've got a positive divided by a negative. Doesn't work. Doesn't work, doesn't work, doesn't work. Kind of stops there. Then here, I've got a negative over a negative. Does it work? Yes. All the way up to 2. Then, I've got a positive divided by a negative. Does it work? So where's the only place where it works? Between 0 and 2. Simple and easy as that. Okay. Everyone all right there? Okay. So what I'm going to do now, ladies and gentlemen, is I'm talking way too much, having too much fun. I'm going to give you guys a few sums that I want you to simply derive. So determine dy over dx. The further study maths, guys, where are you? The further study maths, guys, I'm going to give you your own set of sums. Okay? Okay? I'm going to give you your own set of sums. So for the normal, guys, please derive those 5 for me. Okay? For the calculus, guys, or for the further study maths, guys, the only ones you really need is dy or d over dx of cos x is negative sin x, and d over dx of sin x is cos x, and d over dx of ln x is 1 over x. And if you want to, if for me to be really nice, f of g of x is equal to f accent of g of x times by g accent of x. And that's pretty much it. That's all the rules you need. Go for it. Okay, I'm going to give you guys 9 minutes. Please do those top ones, the AP maths, guys. There's the 3 for you. For a moment, these 4 I give on purpose because each one of them has something in it where the teachers are going to try and catch you up. Because I mark matric papers every year, and every year these sums, like more than half of the kids are going to make stupid mistakes because, oh, it's so easy, sir. If I look at this first one, first of all, I'm going to square the whole bracket out. So I'm sitting here with 4x squared. Please be careful that you don't bring up the 3. I don't care about a 3 in the denominator. Dis die noemer vir die Afrikaanse ountjies, okay? The denominator. Now this I can derive because I don't have brackets, I don't have surds, wortels, and I don't have x's in the denominator. Please understand, grade 12s, do not be flippant about your notation. You are going to lose silly marks if you don't write it out properly. So can I now derive? Yes. Then it becomes dy over dx. 8x plus 1 over 3 x to the negative 2. Okay? So only when you actually derive, then it becomes dy over dx. Do I have to make the exponent positive? Please do. Even if you feel it's a waste of time, please make it positive. If I look at question B, what is standing in my way of deriving? The surds, the wortels, and an x in the denominator. Please, not just a fraction. An x in the denominator. So I've got to use my exponential laws to go and say this is 2x to the half minus 5 over x to the half. And now it's kind of your choice how you take it further. I still can't derive, because there's an x in the denominator. Because it's a monomial in the denominator, I'm going to split up my this gives me 2 minus.
Sir, there's a question here.
Sorry, thank you. I'll get there now.
No, sir, that's my thing.
Is it your thing? Yes, sir.
There's a question.
Who's got a question?
There was a lady here who said she didn't understand the first question.
Okay, thank you, sir. Thank you for... Please be honest. Stop me if I'm going too fast. Yes, yes, miss.
So the thing is, I haven't done calculus yet, so the three of us, we've never done it, we're behind in the syllabus, that's what it's about.
You?
We are behind in the syllabus, so we have not done calculus yet. So can you please explain it in dumb terms, please?
I will gladly. My humblest apologies and thank you for stopping me on that. 100%. Okay? The first step, are you ladies alright with it? I literally just took, I just took that bracket, squared it out. I took the x to the exponent. Okay. Now, when I derive, that's derivatives. What we do is to do the shortcut method. I take the 4 times it by 2 and I subtract 1 from the exponent. Okay? I would love to sit with you ladies and do the explanation about the y. Okay? And then I do the same here. I go with third times by -1. And then I subtract 1 from the exponent. And this is dy over dx. So what I'm doing in this step here, I still haven't done anything that's actually new to calculus. I'm just applying the exponential laws here. So I cannot derive when there's an x in the denominator. So I'm going to take it up and it becomes 5x to the -1/2. You ladies all right with those steps? Now we get to a very important question. I want to go dy over dx. So I'm going to ask the rest of you to be patient, because the ladies still haven't done calculus, and that's all right. Okay? So dy over dx, what is the derivative of 2? Okay. Speaking to you.
0.
Why?
The derivative of a whole number is 0.
Why?
It's a constant.
Because the exponent will become 0 when you have a distant number.
Oh! Again, I know a lot of you, I see my gent there at the back, I'm ignoring him. Just being honest, I'll get you now. Okay? Most of your teachers would have explained it like there's no x, therefore it becomes 0. But that doesn't really solve the question, but why? Yes, sir. I just love your Batman. Yes, sir. No pressure. Why is the derivative of 2 0?
Because there is no x values or roots to
I love the words you're throwing around. The roots and those X's. Yeah, that's fine. Guys, it's okay to not know. That's why you are here. It's not okay to walk away from here and still not know. Yes. Miss, are you there?
Because it's a constant.
And?
I don't know.
I love this. I love this. You're in the trick. You must start asking questions. Yeah, please. I hope if she doesn't answer, you're in. Yeah.
Because 2 would technically be 2x to the power of 0, and if you were to take the power of 0 to 2, it would end up being 0.
Okay. So our ladies then, what she's basically in essence saying is I can change 2 into x to the 0, then bringing the 0 to the front of the x, 2 times 0. That's a fantastic mathematical algebraic explanation. But why?
Because the 2 represents a straight line, a horizontal straight line, and the gradient of that horizontal straight line is 0.
Ladies and gentlemen, well done, Miss. Amazing explanation. The algebraic explanation is fantastic. But the thing that I would love you guys to start doing is take it one step further. Go to the definition. If anybody ever asks you, but why? Your first response must go to a definition. What is the definition of derivatives? Or instantaneous rate of? What is the definition of a constant? It stays the. So what is the rate of change of a constant? Ladies and gentlemen, if you want to do any debating, if you want to do any argumentative speeches, if you want to do your master's and PhD one day, you're going to feel like you're dancing around the fire. Because you're going to be like, I think this is going to happen. And the professor will look at you and go, but why? No, I've done this research. And? What do you mean, and? And then he starts saying, what about this? And you go, oops. Let me go back. And that's literally how masters and PhDs are written. You start with something you think is going to happen. And then you start going back and you start digging deeper. Go to definitions. Go to things that we accept. Like the derivative of a constant means the rate of change of a constant, and that is always 0. Because it is a flat line. Yes, I can put an x to the 0 there, that's fine. And I love it. Plus, because that is 5 over 2, x to the negative 3 over 2. Again, you can make the exponent positive, and that is fine. Now, can I quickly share something that might make your life actually very easy? Something that when you get to further studies and when you get to calculus, your life, when you grasp it, your life's going to be easy. What is the formula for gradient? Everyone is with me, right? What is the difference? The deltas became, because in maths, the moment we go from between 2 points, if we go between 2 points, it's always delta. If we go to at a point, it means we use the terminology or the writing, the notation of d. dy over dx comes from that at a point. Further study maths, guys. If you did integration yet, you would see that the delta x at the end of your integral becomes dx the moment you make it at a point. That's the way we show in maths at a point. The difference, but at a point. I only realized that this year, and I've been teaching for many, many, many years. Sad but true. Okay. What is the problem with question C? Somebody please. Y is not on its own. So therefore for me to get dy over dx, I first must make y the, and then I derive. If we get to further studies and you get things like this, where you cannot make y alone, then you use implicit differentiation. Okay, and some of you are oh, so glad I'm taking further studies. Next year you're not going to be so glad. Hashtag just saying. Okay. When I look at question C, let me get y alone. xy is equal to 5 plus x to the 3 over 2. Y is still not on its own, so y is equal to 5 over x, x to the 3 over 2 over x. So this is 5x to the negative 1 plus x to the half. And now I can derive. Okay? If I look at d, y equal to x to the pi minus, this is another catch-up question, the square root of 2x. How do I write that in a form that is acceptable? Do I do this? Do I do that? No. It's like, really, sir? No, I don't really like to do this, ladies and gentlemen. I don't. Because I don't really care about the square root of 2. That's just a value. I'm just going to go x to the half. I don't care about the square root of 2. I must just keep it inside the root. Inside the surd. Now that I can derive. Again, the derivative of t is 0. Some of you are going, 1! No. Remember, I'm deriving in terms of x. So t is a constant. 4 times a half is 2, square root of 2, x to the negative a half plus 0. So I didn't like that by over 2. I want to write it as 2,140. Just leave it as pi. Leave it as pi. Don't discriminate. Okay. Now, ladies and gentlemen, wow. We haven't even touched the awesome stuff. Ladies and gentlemen, for me, when you start understanding things like calculus, a lot of your problems are going to disappear. At least because if you understand maths, your studying becomes less. Because then you don't have to try and cram all of the knowledge if you actually understand it. If people ask me, why did I not become an actuary like that I studied? And yes, I studied AXI and I finished my degree. But I decided to go away from it because in my second year, I had one of those aha moments when a professor was standing in front of us, 200 AXI students, and he asked a very simple question and he said, but why? And now please get this, if you think you are clever, I don't think you're as clever as some of the AXI guys I studied with. Oh, so you don't know me. You don't know those guys. When you walk out of matric with 16 distinctions, 16, 1-6. You can talk to me again about that you are competing with those guys. Okay. Okay. I'm not making this stuff up. Really. Okay. But ladies and gentlemen, that was just some flexing. But that professor, even that oak that got 16 distinctions, couldn't answer the professor. And that was scary for me as a student who thought I was relatively clever. I only got 3 distinctions. But I realized that my teacher, even though I've got loads of respect for her, she's still teaching to this day, I'm not that old. But she taught me to do maths, not to think maths. She taught me to solve X, but not why am I solving X. And when you start getting to behind the but why, that's when you will start having success, because we don't know what's going to come 5 years or 10 years from now. And there's no textbook that can show you how or why or what's going to happen, because we don't even know. So you've got to learn to ask the but why questions yourself. Start probing. Why is this happening? Why is this? Why is that? Why is it not this? So now we're going to move over to graphs. Okay? Now for the sake of time, ladies and gentlemen, I don't want you to do for me number 2 and let's just skip number 2 for the sake of time, because that's just gradients. But what I would like you to do is question 1, question 3, 4, and then 5. So I'm going to give you 10 minutes and do as many of them as possible so that we can do some other work as well. Go for it. Okay, let's start with that question. Okay, so let's start with that question. The graph of h of x is that. Show that a is 3/2 and b is 6. Now even the ladies that didn't do calculus, you can actually still do this. Even without calculus you can do that, but I want you guys to do it with calculus. Okay, I'm starting to have fun. Can I challenge you guys for a moment with a sum? Okay, please ignore the A coordinate. So try and show that A is 3/2 and B is 6 using only B's coordinate. Only B's coordinate. The other ladies who haven't done calculus, you can do it with both. But I want to challenge you guys to do it using only B's coordinate. Because I have seen that being asked in an exam. Using only one set of coordinates. Okay, so I've now made a question 2 and 3 a follow-up. So I want the point of inflection as well as make a sketch of h accent of x. Okay, ladies and gentlemen, is there some of you that's still stuck on how the hell do I do it with only one set of coordinates? Be honest. Okay, a number of you, I forgive you, okay? There's forgiveness today. The thing is, ladies and gentlemen, I love this. I love this because I've actually seen teachers ask it using one set of coordinates. Now, most of you would get, but again, monkey behind the mountain. I've got my beautiful little monkey here. It's kind of hidden at the moment. The question is, what is the monkey? I'm not trying to catch you out. What is the monkey? The values of A and B. So now I need either a special formula which I don't really have, or what can I do? I need two sets of coordinates. Or not two sets of coordinates, two sets of equations. So most of you, if you look at B, you go and do this. Yay! H accent of 2 is 0, right? And then you kind of do stuff, and then you get to a point that you're like, I'm screwed. Right? Right? I need a second set of coordinates, or second set of equations. What is the second set of equations? Isn't B just a coordinate on the graph? So in other words, h of 2 is equal to 10. Now I can set up two equations and solve simultaneously. So if I look at h of 2, it's negative 2 cubed plus a times 2 squared plus b times 2 being 10, because it's just a set of coordinates. So that gives me 18. So 4a plus 2b is 18. There's one set of coordinates. Or one equation. Why do I keep on saying set of coordinates? Sorry. One equation. H accent of x is negative 3x squared plus 2ax plus b. And if I substitute it by 2, I get 0. And now I've got two sets of equations that I need to solve. So in other words, this gives me b equal to 12 minus 4a, which I can plug in there and solve. If I've got two variables, I either must have a special formula. What special formulas am I talking about? And you guys all just keeping quiet. You're like, I've got no clue what you're talking about, sir. What special formulas am I talking about when I say that? And please, don't feel like an idiot if you say, sir, I got no clue. You're going to walk out of here and you still don't have a clue. What special formulas am I talking about? Say again? No. No. I'm talking about y equal to a, x minus x1, x minus x2, x minus x3. Or y equal to, if I've got a parabola, x minus x1, x minus x2. Or y equal to a, x minus b squared plus q. Those are the special formulas that I'm talking about, where I can solve more than one variable in one go. If I can't use that, I've got to use simultaneous equations. In this case, I can't use this one because I don't have x-intercept. This one is for a parabola, that one's for a parabola, so I can't use it there. Okay, so I don't have a choice. You have to go to simultaneous equations. Anybody got questions on number one? Okay. Number two, the point of inflection. What is the point of inflection? No, don't. How do I determine it? What is the point of inflection? Yes, sir? Any of you? I just love the Batman, okay? Just on preference to the Batman.
So isn't it where the concavity of the graph changes?
It's when the concavity of the graph changes. So it is where the graph goes from this to that, or other way around. How do I determine it? Second derivative equal to 0. Okay? Well, you've got the formula. I've got a silly question. What if I couldn't answer question 1? Sorry, miss, just speak into the mic what you just said.
So, wouldn't you use like the values that they already gave you for A and B? Just substitute it, then get the first derivative, then the second from
And how do you write that for the examiner? Ladies and gents, this is a very, very valuable little technique. Because what she's saying, just selling, boom. But how do I write it for the examiner? Because, do you know who's going to mark your matric final paper? You wish you knew. Some of you like, please not my teacher. My teacher. You don't know. So remember, a little bit of advice. Someone asked me yesterday, so I think it was you. So that fine line between when am I writing too much and when am I writing too little. You asked me that yesterday, right? Yeah. Or was it someone else? It was you. Let me quickly share with you, sir, a secret. that I learned way too late in my life when I wrote my postgraduate degree in education. 50% of an exam is writing your knowledge on paper. The other 50% is making the examiner understand what you wrote down. There's a difference between the two. Because remember, you don't know what's going on in their mind when they are marking. So you've got to learn to make the work easy for the person that's going to mark your exam. So if I can't do A, but now I want to use the values in B, what do I tell the examiner? One little word. Assume. That's what you write. Assume A is this, B is that, and then you just do the rest of the paper. Because then the examiner knows you assumed that A is that, and now you can still do all the rest. The biggest mistake that especially grade 11s, some grade 12s do, is they can't do A. Let me leave everything open, okay? I'm stupid. No, we guide you into this. So, if you can't do A, let's say you get to this point and you're like, oh man, I got no clue. Let me skip to 2 and go, assume A is 3 over 2 and B is 6. Therefore, h of x is negative x cubed plus 3 over 2x squared. Is that a negative? No, plus 6x. And now I answer all the rest. So h accent of x, negative 3x squared, plus 3x, h double accent of x, derive it again, negative 6x plus 3, make it equal to 0. X is half. How can I do this in 2 steps? Remember what I said yesterday? If you want to really challenge yourself, find more than one way of doing it. Yes, sir. Into the mic.
Isn't it the half of the 2 x's?
What 2 x's?
The turning point's 2 x's.
Oh my goodness! A point of inflection is always exactly in between the 2 turning points of a cubic. Why is that, sir? It's because it's 100% right. It is true, but why?
Because the second derivative's turning point is between of the point of inflection becomes the second derivative's x value.
Okay? You unfortunately shot yourself in the foot there, but it's okay. Because again, another trick, and I was laughing this morning just before you guys walked in. One of the ladies were like, I don't know how to do this, but explaining it. Yo, sir. Am I right? The other lady's just laughing, going, so really? You had to tell that to everyone? I won't look in your direction, I promise. Okay. You're 100% right with kind of where you're going. Ladies and gentlemen, the first order derivative is a what? Is a everyone? Parabola. How do I know that? It's a flippin' square, guys. Okay. sketch of h accent of x. Now I'm going to quickly draw h of x on this board. Okay, so there is h of x. Now some of you are already, your teachers have pre-programmed you and said, okay, it is a negative cubic function, so imagine. Okay. And then is h accent of x. And that's right. Okay? Is there some of you that's looking at that and going, Hyperbola? Okay. Is there some of you that have no clue why I drew it in that way? Okay, there's at least one or two of you that's honest. Okay. I'm joking. What does h accent of x represent? And please again, I know teachers go, you see this, you just do that. Don't think like that. Think about what does it represent. What does h accent of x represent? Let's please, yes. Okay, fortunately the lady behind is answering. Yeah. No, that is h to the negative 1. Please be careful. Try again. Oh, come on, you've been doing derivatives the whole day. Yes. Your mic is on. I mean, I can't do anything bad. And now you guys are pointing fingers at each other. Yes, sir? Okay, so it's the derivative, which means what? The gradient. So, again, when I want to sketch this, what am I looking for? The gradient. So now remember, if I analyze this, I'm going to do it in a circle. My gradient is negative, right? All the way up to that point there, where my gradient is 0. H accent of x is 0. Then my gradient becomes positive. My gradient is positive all the way up to there, where my gradient is 0. Then my gradient becomes negative. Is everyone with me? So in my parabola now, remember, now this represents position. The y value, we're talking about the gradient. So I've got two places that is important. I've got the turning point. I've got that turning point there. This is at -1 and this is at 2. At these two places, the gradient is, so the y value is, so at 2 and at -1, h accent of x is 0. In between these 2 points, the gradient is positive. So the gradient is positive. But on this side, the gradient is negative, so my y value is negative. On that side of 2, the gradient is negative, so the y value is negative. And that's why it's an upside down parabola. Okay. I want you guys to quickly, I'm going to give you just a few minutes. I'm going to give you 2 graphs, and I'm going to ask you draw the originals for me. So I'm going to give you the derivative, and I'm going to ask you draw the original. Now I'm going to have fun. There is one of them, and the other one please, for those 2 graphs, draw the original ones for me. Let me try and erase a bit around it so it's a bit clearer. What I quickly want to get back to, sirs, you said we kind of got derailed. Let's circle back. If this, ladies and gentlemen, is your derivative, what would be, how would we determine that point? Someone tell me. What is that point? The x value of the turning point. Now, how do I determine that? But let's forget about negative b over 2a. You can derive again. So if I derive this another time, I get f double accent, right? And I make it equal to, but that is the point of inflection, which is exactly in the middle of the 2 turning points of the original graph. So that is a very important little side note, that if you've got the 2 turning points, I can get the point of inflection of a cubic by just going exactly in the middle at x equal to 1. But now, how do I draw this graph? Now, if your teacher didn't show you that just it's like this, then let's interpret. Here I've got y values that are positive, and there also I've got y values that are positive, but here I've got y values that are negative. I hope you understand that. If you don't, please come and see me. Okay, I'll talk through it with you again. But what does y represent? The gradient. So actually here at that part thing, I'm telling you that f accent x is bigger than naught. Look at my reason, which means what about fx? F of x is increasing. Look at my way of reasoning. F is increasing on the left of -2. So if I draw that, I've got -2 as being something special. I've got 4 to be something special. On the left of negative, my graph is increasing. At at -2 and at 4, the y values are 0, but y represents f accent of x being 0, which is the turning points or the stationary points of f. So my graph is stationary somewhere at 2, somewhere at 4. Between -2 and 4, y is smaller than 0, but y again is f accent x, smaller than 0, so my graph has to be decreasing, and then be flat, and then on the right of 4 increase. So how will my graph look? Ah, that's not bad. That's not good at all. There we go. And there I've got a rough sketch of f of x. But so how do you know it cuts the x-axis 3 times? I don't. This graph could be like this. That's why we say a rough sketch. Because we don't care about x-intercepts, we just care about the form of the graph. For me to know more, I have to have more information. Now I'm giving this one, I gave you guys this one on purpose. Because most of you would not have seen one like that in your life. Hashtag prelims, here we come. Okay. What does that graph tell me of g of x? Say again? Okay, can I quickly tell you a secret? All cubics will have one x-intercept, at least. And you can accept that, and then one day you'll, or maybe in an hour or two, you go, but why is that? Why is that? Interesting. Yes, sir? Mic for me, please.
So the point of inflection is the stationary point.
Okay, so first of all, I want to ask you, is there a stationary point? No, let's not go technically. It's a yes or no?
Yes.
Yes, there is. There is a stationary point here. Because y is 0, and therefore g accent is 0, which means at x equal to 3, somewhere my graph is going to be stationary. But now what else do I have? What's happening the rest of the time? If this is the only place where y is 0, what's happening the rest of the time? Is y positive or is y negative? In this case, come on, grade 12s, y is negative. So in other words, the y's are negative everywhere except there. But what does y represent? G accent of x. And what does this tell me about gx? It's decreasing. So in other words, my gx is decreasing everywhere except at x equal to 3. So how does that cubic graph look? It goes down, flattens, and goes down. So is there an x-intercept? Yes, there is. Now I want to ask you, sir, with a Batman. I just love it in your shirt. Will all cubics have stationary points? Matter why?
No, sorry, yes, well, cube graphs will have stationary points.
Now you're saying yes, matter why?
So please enlighten us.
That's a cop-out, man. Ladies and gents, what about it? Now here's a beautiful thing, and this is something you need to learn. If I want to disprove you, I only need one example. Because I can draw a cubic like this. That thing doesn't turn anyway. So no, not all cubics have. Now the question is, matter why, sir? Because, ladies and gentlemen, I'm just awesome that way. I know these things. Now that's a cop-out. So can I quickly share with you why not all cubics have turning points or stationary points? What is the standard formula for a cubic? ax cubed plus bx squared plus cx plus d, right? Look what I'm doing. To prove something, I go to the definition. How do I determine the stationary points of this graph? Derive, put equal to. So I'm going to sit here with 3ax squared plus 2bx plus c equal to. Does this equation have real roots everywhere? No, it doesn't. This is a quadratic equation which are somewhere going to have non-real roots, right? So therefore it's not going to be able to have real solutions everywhere. So in this case we can actually get certain pockets where trying to solve it will give me non-real solutions. So there won't be stationary points. Oh, this is beautiful. I'm just in my mind thinking about future exam questions. I love it. Ladies and gentlemen, take a snapshot, whoop out those phones, take a shot of that one. Okay, little baby, when the lights go. Everything goes out apparently. Okay, that is your homework for tomorrow. Okay, the first person tomorrow morning to come and show me the correct answer for this, for both of them, will get a slab chocolate. A bubbly. A nice one. No, don't be, come on, I'm a teacher. Yeah, I can't afford Lint or those fancy ones, okay? I didn't go to private school. I just teach them. Ladies and gentlemen, just give me your attention for a moment. Give me your attention for a moment. These kind of questions is crucial for first year calculus. and differential equations and partial differential equations you're going to do in your second year. Am I right, Mr. Francis? He studied applied maths, so he will kind of know, okay? Ladies and gentlemen, thank you for being such sports today and for having fun with me. Tomorrow we're going to do trigonometry. So you need to be switched on from 8 o'clock. Have a beautiful rest of your day. See you tomorrow. Cheers.